Today we're going to be investigating unbalanced forces using the Forces and Motion Basics simulation. I have that embedded for you on the actual Canvas assignment, but you can also head over to the website as well if you want to view it larger. So you're going to open that slideshow. On the slideshow, there are step-by-step directions on each of the slides and yellow boxes for where you will add your responses. I'm sorry it's taking forever to load. It's going to have two of them open. Let's see if that helps. Okay. So today we're going to predict how forces can change motion, and we're going to provide reasoning and evidence to explain motion changing or not changing. So first up, it says open the Force and Motion Basic Simulation and play with the friction screen for a few minutes. So I'm going to slide over so I can show two screens at once. And I'm going to pull it out. Okay, so I'm going to have my simulation open on the left-hand side and my instructions open on the right-hand side. If you're able to split screens, that can be quite nice to work with. So it says that we're going to be going to the friction simulation. So this is kind of small. I mean, if you want to go to the actual PhET website, that might help to make it a little bigger if it's too small for you. Okay, so it says to just play around for a few minutes. So I want you to try a variety of things, adding force to see what happens. You can add people onto the boxes to see what happens. I can give force from the different direction and see what happens. I just want you to play around with it for a few minutes, okay? Once you play around with the simulation for a couple of minutes, then you'll be ready to answer question A and B on the slide. So first up, how does the friction screen differ from the net force and motion screens? So I want you to take a look. So we've already played around with the net force screen. Okay, we did that. That's with the Candy tug of war. And then the motion screen looks an awful lot like the friction screen. Okay, but I want you to find the differences. How are they different? So what is different between them? And then what is something that you discovered? It says you're playing around. What did you discover as you were playing with the friction simulation? Okay, slide 2. We're still using the same simulation. Go ahead and stop it. It says, imagine that your friend Sam is trying to move a box. Using what you learned by exploring, draw arrows to predict what might happen in the picture below. I want you to try this part out first without using the simulation. And you're going to just add arrows to tell me what you think is going to happen. If you're not quite sure how to use arrows, I do have an extra video on the slideshow. I'll show you real quick right now. You can go up to this little drop down right here. It's probably set at line, so it probably looks like this. When you go to drop down, you can choose arrow, and it'll let you draw an arrow. You can change the weight of the arrow right there. You can change the color. I can move that arrow in different directions. And I'm going to be changing that arrow and adding it to each of the pictures of what I think is going to happen. So what do you think is going to happen when Sam is not pushing the box? What will happen to the box? When Sam is pushing the box, that the box is not moving. And then Sam pushing and box is moving. So which way do you think it's going to be moving? Okay. Check your sketches using the simulation and make corrections to your drawings if needed. List any new ideas you discovered. So once you say what you think is going to happen to the box by using arrows, I want you to go back to the simulation and try it out. So here it is, Sam not doing anything. Then Sam pushing and nothing happening. Okay, I'm going to stop it. I don't want to show what's going to happen. And I want you to answer here. Then what did you notice about the similarities and differences between the applied force arrow and the friction force arrows in each simulation? So so right here, the red arrow shows the friction force. The orange arrow shows the applied force. So as you're doing the simulation, what do you notice is similar and different between them? Okay, on the next slide. Have Sam try to move the refrigerator. What's different from pushing the box? Draw the sum forces arrows for the different cases. So this time, you're going to be putting in a sum of the forces arrows, just like is on the simulation, but you're going to have the refrigerator going. So move the box, put the refrigerator in, and add in those forces. And we can go ahead and click on the sum of forces. It'll give you the value, but really you can just do the arrows, okay? And so I'm going to press, these are the arrows I want drawn on the refrigerator. So you're just going to be putting those over onto your pictures. So were you able to move the refrigerator? If not, what would you have to change? Describe what you did. So what did you have to do in order to get the refrigerator to move, or were you never able to get it to move? Try pushing other things. You can even stack them, as I showed you before. I can stack the people and the trash can on top of the refrigerator. And what did you discover as you keep adding things onto the top of the refrigerator? Okay, then that leads us into you trying out some different simulations. So using the PhET force and motion basic simulation, demonstrate how an unbalanced force can change an object's motion. So you're going to try some things out. Okay, so maybe you want to try out, let's see, what it takes to cause unbalanced forces on these boxes. Okay, so once you remember, unbalanced forces means there's some change in the speed or direction of the object. So something has happened. Right now they're at rest. They're not moving. What do you need to do to get them moving? Once you figure that out, take a screenshot. Remember on the force in the PhET simulations, those three little dots at the bottom allow us to take a picture. I'm going to go ahead and try this one out. Okay, I caused an unbalanced force. That box is moving now. So I'm going to take a picture of my situation. Take a screenshot. Okay, so I captured that. I can see in this case that my applied force arrow is greater than my friction force arrow. So I have unbalanced forces. They are not currently balanced. When I balance them, as they're balanced, I see that nothing happens. Okay, it stays exactly how it was. So right there, they're balanced. They're balanced. As soon as they are unbalanced, I see there's a change in motion. It goes from at rest to actually moving. Okay, so once I get that screenshot of a situation where I have unbalanced forces causing an object's motion to change, either its speed or direction, I'm going to take a screenshot of the simulation that shows that. I'm going to insert it into my slideshow, and then I'm going to describe how it changed. So, describe how the unbalanced force changed the object's position. So, the box was at rest, sitting on the ground. The unbalanced force caused the object's position to change by moving to the left, away from the mountains in the background. Remember, position is in relation to something. So I'm relating it to the mountains that were in the background. Okay. Next up, I'm going to show again how unbalanced forces can change an object's speed. I'm going to set up a simulation once again in the PhET simulation. Take a screenshot when I have achieved unbalanced forces, and then I'm going to describe how the object's speed changed. So if I was using the same simulation or picture from the simulation, I would say that the boxes were at rest and then they began to move. So that's definitely a change in speed. And then finally, direction. How did the direction change? So if I'm wanting to change direction, in this case, one thing I might do on this one is I have it moving, and then all of a sudden I switch my forces to the other side and make it start moving the other direction. I could also do this in the motion simulation with the skateboard, I could also use the tug of war. Okay, so you don't have to use just that friction simulation. You can choose a different simulation if you want. But in right here, I'm going to be describing then how those unbalanced forces change the direction. Okay, I'll be available on Zoom if you have any questions.